Hello everyone and welcome to our new video. And today's video is another day of changing a function into a polynomial. And that today's function will be cosine x. So here we have our function cosine x. And since we want it to be a polynomials form, we will set it and equal it to a polynomials equation. So we can make up anything, but I just always use c sub 0 starting off, and then plus c sub 1 times x plus c sub 2 times x to the power of 2 plus c sub 3 times x to the power of 3 plus, let me just see that's all lined up, and I can see that it's not. So quickly, c sub 1 times x plus c sub 2 times x to the power of 2 plus c sub 3 times x to the power of 3 plus c sub 4 times x to the power of 4 and plus c sub 5 times x to the power of 5 and plus dot dot dot, because it goes on for forever. Now putting all of that aside, we will write our function cosine x, and we will set the x as 0. So then we have f0, and cosine 0 is 1, obviously, and then we will differentiate this function. So we have f prime x, which is equal to negative sine x, then taking a 0 of x, so we have f prime 0, which is equal to negative sine x1, negative sine 0 is just 0. Then we will differentiate this function now. So we have negative sine x prime is f prime prime x is equal to negative cosine x. So setting 0 to x, we have f prime prime 0, which is equal to negative 1. Then differentiating this negative cosine x, now we have f prime 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 x, which is then is equal to sine x. Then we take the 0 for the x's placement, so we have f prime 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 0 is equal to 0. Taking the derivative of sine x, we have f prime prime. Actually, no, we won't be using primes anymore because then it's just too long. So we have f to the power of 5 x is equal to cosine x. So f to the power of 0 then is equal to 1. So there we have our loop. Then differentiating cosine x. Wait, oops, it's not power of 4, it's actually not power of 5, it's actually power of 4. And continuing on, we will differentiate the cosine x now. So we have f to the power of 5 x, which is equal to negative sine x. So our f to the power of 0 then is equal to 0. We will set the x as 0 for our original very long function. So when we set the x as 0, we have f0 is equal to c sub 0, because x times this, 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 and so on. X is just 0, so everything is just deleted. So now, but here it says that f0 is 1. So our c sub 0 is 1. C sub 0 is equal to 1. Now we will differentiate this function. So we get f prime x is equal to c sub 1 plus 2 times c sub 2 times x plus 3 times c sub 3 times x to the power of 2 times 4 times c sub 4 times x to the power of 3 plus 5 times c sub 5 times x to the power of 4 plus dot dot dot. Now again, setting the x as 0, we get f prime 0 is equal to just c sub 1. And here it says that f prime 0 is equal to 0, so our c sub 1 is equal to 0. So c sub 1 is equal to 0. Now differentiating this function now, we have f prime prime x then is equal to 2 times c sub 2 plus 2 times 3 times c sub 3 times x plus 3 times 4 times c sub 4 times x to the power of 2 times 4 times 5 times x to the power of 5 times x to the power of 3 and plus dot dot dot. Now again, setting x as is equal to 0, we have f prime prime 0. We have what are left over is 2 times c sub 2. And here it says that f prime prime 0 is equal to -1, so our 2 times c sub 2 is equal to -1. So our value for c sub 2 is 1 over 2, -1 over 2. Now we will differentiate this function now. So we have f prime 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 x, which is equal to 2 times 3 times c sub 3 plus 2 times 3 times 4 times c sub 4 times x plus 3 times 4 times 5 times c sub 5 times x to the power of 2 plus dot dot dot. Now again, we will set the x as equal to 0, so we have f prime 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 0 is equal to 2 times 3 times c to the power of 3. And here it says that f prime 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 0 is equal to 0, so our value for our c sub 3 is equal to 0. Now derivating this function, we have f to the power of 4 x is equal to 2 times 3 times 4 times c sub 4 plus 2 times 3 times 4 times 5 times c sub 5 times x and plus dot dot dot. Now replacing x as 0, we have f to the power of 4, 0, which is then is equal to 2 times 3 times 4 times c sub 4. And here it says that f to the power of 4, 0 is equal to 1, so our value for c sub 4 is equal to 1 over 2 times 3 times 4. Now differentiating this function now, we have f to the power of 5x, which is equal to 2 times 3 times 4 times 5 and c sub 5. Then replacing x as 0, we have f to the power of 5, 0, which is equal to 2 times 3 times 4 times 5 times c sub 5. Oh yeah, and I need plus dot 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 here. For replacing as it 0, those plus dot 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 is just getting cancelled. So yeah, and here it says that f to the power of 5, 0 is equal to 0. So we just got our value of c5 is equal to 0. We won't be needing all this very long notes anymore. So those are gonna have to go away because we need this room for something else to write on. Now, of what we got in here, we will simply replace those into our cosine x is equal to polynomials equation. So our c sub 0 is equal to 1. So cosine x is equal to 1 and c sub 1 is equal to 0 times x is just nothing there. C sub 2 is equal to -1 over 2 times x to the power of 2 is negative x to the power of 2 over 2. And plus c sub 3 is 0, so nothing goes there, and c sub 4 is equal to, and times x to the power 4 is x to the power 4 over 2 times 3 times 4. And finally, c sub 5 is equal to 0 times x to the power 5 is just 0, so 1 plus dot dot dot. Looking at this very few given hints, we can actually still find a rhyme going on here. And as you can see, the first term is positive, the negative positive, so then we are expected to see the next term as being a negative. Also, our terms, our second term is x to the power of 2, then it is x to the power of 4. Adding 2 for our next term's x's power. So here we will see x to the power of 6, and on the bottom, we first have to notice that all of this term is in a, what's it called? This sign thing. Wait, I'm so stupid. Factorial, oh my god. How did I forget that? So we will just rewrite all of this thing. So we have 1 over 0 factorial minus x to the power of 2 over 2 factorial plus x to the power of 4 over 4 factorial and minus x to the power of 6. Pretty common sense. This is 6 factorial and plus dot dot dot. Keep forgetting that. From our previous video, we found out that the sin x being written down in a polynomials form is 1 over 1 factorial minus x to the power of 3 over 3 factorial plus 5 to the power, x to the power of 5 over 5 factorial and minus x to the power of 7 over 7 factorial plus dot dot dot. Since sin x is a odd function, we have the x's power being odd. You guys can see 3, 5, 7. And also since cosine x is a even function, we have the variable x as being powered by even numbers. So see 2, 4, 6. So right here, we just found our answer for changing our function cosine x into a polynomials form. So we are done right now. Thanks for watching and see you guys in the next video. Bye.